Hi, my name is Arij Jahangir, and I'm studying the use of remote sensing for research on aviation contrails. Aviation-induced climate change consists of many factors, including changes in the global cirrus cloudiness. Currently, aviation is responsible for approximately 3% of fossil fuel carbon emissions and 2 to 14% of anthropogenic climate forcing. With this current trend, climate forcing could potentially triple by 2050. Researching aviation's impact on the climate has now become an important subject to both public and political attention. In addition to the clear consequences of emissions on climate, aviation has an even greater impact with the formation of condensation trails, or contrails, produced while the aircraft is running. Ice crystals at high altitudes of the atmosphere act as triggers for cloud formation. The exhaust in aircraft create nucleation for moisture and water vapor. The aircraft fuel causes hydrocarbon fuel to burn with oxygen, producing emissions comprised of carbon dioxide, water vapor, nitrogen oxides, sulfur oxides, and aerosol particles. Contrails are line-shaped streams created through a reaction combining hot, moist air emitted from the engine with cold ambient air. The cause of line-shaped contrails towards radiative forcing is predicted to surge significantly with the expected increase in air traffic, thus causing aviation to play an even greater part in climate change. Cirrus clouds are then formed from the line-shaped contrails, and the atmosphere is supersaturated as a consequence of the water content. An increase in cirrus cloud cover has been observed in areas with high air traffic density compared to areas nearby with less air traffic. Through tracking the effect of contrails and natural cirrus separately, radiative forcing can be measured separately from spreading contrails. The outcome of spreading contrails is measured to be approximately 38 milliwatt per meter squared, which can be compared to radiative forcing from young contrails at 4 milliwatts per meter squared and from aviation carbon dioxide at 28 milliwatts per meter squared. While contrails have a short lifespan, their radiative impact at one time is greater than all of the aviation emitted carbon dioxide gathered in the atmosphere to this date. However, the carbon dioxide emissions continue to create a warming effect for a much longer period than contrails do. Rerouting aircraft to avoid atmospheric areas supersaturated in terms of ice has been considered. However, it is necessary to also confirm that an increase in carbon dioxide emissions would not surpass the potential consequences of contrails. Satellite imagery can identify line-shaped contrails. The contrast in brightness temperature between the contrails and the surrounding area is great enough. The contrast varies on many factors though, which include the optical depth of the contrails, the geometric range, the presence of natural clouds, and the underlying surface conditions. Regional line-shaped contrail coverage has been depicted through satellite imaging. The satellite infrared images show contrails spreading into cirrus clouds. The young contrails can be seen as the sharp lines and spring shapes in the first image. This gradually becomes cirrus clouds. The cirrus clouds are seen as the bright white regions in the lower images. At the bottom right of each image, the time taken and the satellite used are given. A study conducted by Bukhar and Karshay suggests that the spreading contrails cause more climate warming than the line-shaped contrails, and therefore they are the main climate forcing cause in aviation. Satellite imagery suggests that the line-shaped contrail coverage could be as much as 3% in areas as large as 60,000 kilometers squared. Since contrails can be covered by natural cloud or not detectable by passive or remote sensors, the actual contrail coverage could actually be greater than we expect.